those as well because we may use some of those formulas today also. So really quickly, and maybe without looking at your formula sheet, see if you can remind me, volume of a prism or a cone, or sorry, prism or a cylinder. Good, volume equals capital BH. Volume of a cube or hexahedron, side cubed. Surface area for a prism or cylinder, pH plus 2B. And what part of that is the lateral area if they want that? pH. Okay, so today we are going to talk about the pyramids and the cones. So we're going to come up with 3 more formulas today. I'll write those in a different color. So we're going to have a formula for the volume of a pyramid or a cone, anything that comes to a point. We're going to have a formula for surface area of a pyramid or a cone. And once again, in that surface area formula will be your lateral area formula. So it's really not another formula to memorize, but on your formula sheet, it's going to be another blank for you to fill in, okay? So you're going to find the lateral area for a pyramid or a cone. And these formulas will work for any pyramid and any cone with one exception. The surface area formula that we're going to learn today, which we haven't written down yet, but you can go ahead and leave some space for it, and then out to the side, you need to write yourself a note. The surface area for a pyramid or cone only works for regular pyramids or cones. The formula I'm going to teach you will only work if your base is regular. Base is regular, so meaning a square, an equilateral triangle, a regular pentagon, a regular hexagon, a regular heptagon. So only if it's regular. What is a 4-dimensional shape that we've talked a lot about? Not 4-dimensional. What is a quadrilateral that we've talked a lot about that's not regular? Basic quadrilateral that you've probably learned way back in elementary school that's not regular. Not a square, but a rectangle. First example in your notes is going to be about a rectangular pyramid. You cannot use the formula for surface area for a rectangular pyramid because it is not regular. Very important. If all else fails, when you get to surface area, if this shape is not regular, the base shape is not regular, the rest of the figure is going to be triangles today, right? Because it's a pyramid. So if your base shape is not regular, then you have to think about it as a net, and you have to find the area of every single face and add them all together. Okay? And that's what you did back before you ever came to geometry. So worst case scenario, you'll find the area of every single piece separately. Okay? And if we have time, we're going to work the one in the notes that is not regular. Okay? But we're going to skip it at first and come back to it. So first formula we're going to talk about is volume. The notes goes through and explains where the volume formula comes from. I'm just going to do a different illustration up here, make it a little easier. So first of all, would you agree that my cone and my cylinder have the same size base circle? Agreed? Okay, so they have the same base. Would you agree that they have the same height if you're going from the vertex to the base? Can you tell that those are the same height? Okay, close enough. So how many cones would it take to fill up this cylinder? If I fill up this cone with water and I pour it into the cylinder, how many of these cones do you think it'll take to fill up this cylinder? Same base, same height. It's actually 3. You were right the first time. If you don't believe me, you can come in. These have little open holes in them. You can take these out to the water fountain. You can fill this cone up with water. You can pour it into the cylinder. And you can see if it really does take 3 of them. But to save time and to not make such a mess up here, I'm not going to actually show you that. You can do that, though, if you don't trust me. But it takes 3 cones to fill up a cylinder. The same thing would happen if you had a pyramid and a prism with the same base. It would take 3 pyramids to fill up the same size prism. So if the volume yesterday was capital BH for a prism, what's going to be the volume today for our pyramid? 1/3 of that. You can take the volume from yesterday and divide it by 3. So that is your volume formula for anything that comes to a point, which means really all you have to do extra today is just divide the volume you did yesterday by 3 or multiply it by 1/3. That is not difficult. So volume is 1/3 area of the base times the height if it's a pyramid or a cone. Okay, here's what's going to make it hard. They are not always going to give you the height. I'll start with the cone because it's easier. They are sometimes going to give you what I already mentioned to you back the first day. Sometimes they're going to give you what's called the slant height, which for the cone is just the slanted height. Does everybody see that? The slant height, the H height, and what is this? The radius. Those make a right triangle. So the extra step today is you may need the H height, but they may give you the slant height and the radius, and you're going to have to do Pythagorean theorem to find your H height. Does that make sense? Okay, the cones are easier. When you get to the pyramid, it has a lot of different measurements on it. So you want to be careful. So look up here with me and make sure you can visualize this. I'm going to say this again. I said it, I think, the other day. This edge is not the slant height. It's slanted, but it's not what we call the slant height. The slant height is the height of the triangular face. Does everybody see? That's the slant height. That is not this edge. Are we clear? Okay, so your slant height, your H height, and this little piece, which will end up on a square being just half this base edge. Do you see that? That's going to form a right triangle, and you could find the slant height or the H height, depending on what you're looking for. So maybe you need the H height for volume. They give you the slant height. They give you the edge length. You can make a right triangle. Okay, it's going to get a little bit harder. Look up here again. Sometimes they're going to give you this edge length and this edge length. So you may first have to find your slant height by using this right triangle. And then you can find your H height by using this right triangle. Do you see the difference? So again, I'm going to show you edge and slant height and half this base edge. Do you see that right triangle? All right. And then you could use that slant height and H height and half this base edge to find your H height again with that right triangle. Not so bad on the square, but here's where it gets ugly. Octagon. Okay, don't zone out. Look up here. What is this distance here? Do you guys see that we're going from the center to the side? That's not the radius. And that distance is not half of this base edge. Do you see that this distance is not half of this base edge? Whereas on the square, it was. That made the square easier. This distance that we're looking at here is the apothem. And so that's where it gets a little harder. You have to find the apothem and use your slant height and your H height to make your right triangle. So it's apothem, H height, slant height makes a right triangle. Do you see the right triangle there? Or it could be half your base edge, the lateral edge, and your slant height. That's going to happen a lot less, but that could be something they give you. Okay, hardest part today is trying to figure out what right triangle do I have, what are my measurements, how do I use Pythagorean theorem to find what I'm looking for. My advice, when you get to your pictures, draw your right triangle in there. Here's your slant height. Here is half of this base edge. Here's your H height. And then look at that right triangle in your picture and then do your Pythagorean theorem. Okay? Are we all really with me on that whole idea of slant height? Okay, that's the hardest part. So that's volume. When you get to surface area, I want you to understand where this formula comes from so that maybe you'll be able to memorize it better. So look up here. I'm going to use this one. Worst case scenario, you get to the ACT Aspire, you forgot the formula. You go back to what you learned before geometry. If you want to find the surface area of this shape, find the area of every triangle, find the area of the square, add them all together. Are we good with that? Okay, but some of the problems get harder today, and so we're trying to work those harder problems easier with a formula. So I want you to think about how you're actually finding the area of a triangle. What's the formula for area of a triangle? Base times height divided by 2, or 1/2 base times height. So think about this. This would be my base, right? With me? And the height of the triangle, when I fold it up, is what in our concept today? Slant height, right? The height of the triangle, which is the height of the face, is your slant height. So what we're really saying is take this base edge times 1/2 times the slant height. Agree? And we would do that how many times? 4. Well, what is the base edge times 4? What's this base edge times 4? That's just the perimeter, right? Are you with me? So if we did 1/2 the perimeter times the slant height, that would give us the area of all the triangles, because we're basically doing 1/2 the base times the height, base, 1/2 base times height, but we just did all the bases together and found the perimeter. So this is going to calculate the area of all the triangles, and then all we need to do is add in the one base. Are you with me? Okay, so that's your formula for surface area. Write it down on your formula sheet right now. Everybody with me? Surface area today is 1/2 capital PL plus B. And remember, what are the only types of pyramids we can use that on? Regular. But you can use it for every cone. Every cone has a circle and it works for a cone, but only for regular pyramids. Okay, what part of that formula is the lateral height? The 1/2 PL. Remember, or sorry, L is the lateral height. I said you were right. What I said is not what I meant to say, Christian. Good job. What part of that is the lateral area? What part is the lateral area for this one? 1/2 PL. Everything except your base. So on your formula sheet, it's not a new formula to memorize. Lateral area is everything except the base. Take off the base. 1/2 PL. Just like last class period, lateral area was everything except the 2 bases. Okay, we're going to work some problems. I'm going to start with the cone because it's easier, and then we'll come back to the problems that are harder. So jump ahead in your notes all the way to the cones. And I'm going to skip the easy cone, and we're going to go to the harder cone. So find the second example like this. Okay? So we're going to find the volume of a cone with a base circumference of 25 pi inches. Everybody with me where we're at in the notes? All right. Volume of a cone. What's my formula? 1/3 BH. All right. What are they giving me when they give me the base circumference? Careful. Very good, Martin. If they're giving me the base circumference, they're giving me the base circumference, which is the perimeter of the base, right? So they're giving me capital P, which they told me is 25 pi. That's the circumference, and for a circle, we call it circumference, but it's also P for perimeter. And then they tell me, what about the height? 2 inches more than twice the radius. How could we write that as an expression? Very good. Twice the radius, 2 inches more. So twice the radius plus 2. 2r plus 2. Okay. What are we going to have to find r? Or excuse me, what are we going to have to find the height? R. How are we going to find R? Okay, what we know the circumference is 25 pi. What's the formula? Exactly. So we're going to take our circumference formula, 2 pi r, set it equal to 25 pi. What will we do to solve for r? Divide by 2 pi. So what is r? 12.5. Once we know r, we should be able to find the height. So let's plug that 12.5 in for r. We have 2 times 12.5 plus 2, bless you. What's 2 times 12.5? 25 plus 2, 27. So we now know that the height is 27. What else do we need for that volume? Area of the base. What is the formula for capital B for a cone? It's a circle, so it's pi r squared. All right, plug in your radius, which was 12.5, and square it. What's 12.5 squared? Very good. So we have 56.25 pi. Oh, sorry, 156.25 pi. Is that correct? Okay, so that is our area of our base. We're going to plug it in. So we have 1/3 of 156.25 pi times the height, which we said was 27. Does it say to round anywhere? No, so we're going to type everything in except pi and leave our answer in terms of pi. So go ahead and do 156.25 times 27 times 1/3. Tell me what you get. I heard 1,406.25. Somebody agree with Christian? So 1,406.25 pi. Again, I would encourage you to start putting those commas to separate your thousands, your millions, to make sure that you are writing correct mathematically. What are your units? Inches cubed. Any questions on volume of a cone here, working backwards? Okay, that had nothing to do with slant height. So let's work somewhere we have some slant height. Actually, I'm going to go to, this one's pretty easy. Let's just talk about this. Is this the next one in your notes? Okay, this one, if I wanted to find the volume, they're giving me the what? Slant height. So what am I going to have to do to find the h height? Pythagorean theorem. Okay, so I'm not going to work this one because it's pretty easy with the cone, but everybody understand you'd have to do Pythagorean theorem? And then you could find the area of the base and it would be easy. Okay, let's go to one that's a little harder. So I'm going to stop doing cones now and let's go back to the beginning. And we're going to skip the first example and go on to the hexagonal pyramid. All right, and this is where it gets harder. All right, so what does it want us to find? Volume and surface area. All right, and it's a hexagonal pyramid, and what does it tell us about our height? It's equal to the apothem. So right now we know the height equals the apothem. I would write that down. Dissect your problem. You're trying to find the volume, and then you're going to find the surface area. What's the formula today for volume? 1/3 capital BH. Okay, we know that in order to find the height, we're going to have to find what? The apothem, okay? To find the area of the base, because it's a hexagon, what is one option for finding the area of a hexagon? 6 equilateral triangles. And you can still do it that way for this one if you want to, but because we're going to have to find the apothem anyway, I'm going to go ahead and work this one like we would have to work if it was a pentagon, an octagon, a decagon. What's our other formula for area of a regular polygon? 1/2 apothem times perimeter. So because I'm going to need the apothem anyway, I'm going to go ahead and work the area of the base that way. All right, so first let's find our perimeter. That's pretty easy. Capital P, how do we find the perimeter of the base? 12 times 6. We've got 6 sides. They're each 12. What is 12 times 6? 72. Plug that in. We have 1/2. We still need to find our apothem times 72. Okay, how do I find the apothem? Okay, first thing I have to do is draw in my central angle and do 360 divided by the number of sides to find that central angle. So my central angle is equal to 360 divided by 6, which is 60. Still seeing a few people who want to then say that when they draw in their apothem, that right triangle, bless you, has an angle at the top of 60. Be careful. The angle at the top here is not 60 in the right triangle. Sorry, 60 is the whole angle. So when you draw in that apothem, this angle becomes 30. So don't forget to divide that angle in half. Okay? So you draw in your apothem, splits the central angle. It also splits the base edge. So instead of this whole thing being 12, we can now split it. And what is this little piece? 6. So in our right triangle, this is 6, and this is our apothem. It is a right triangle with an angle of 30, so that makes it a special 30, 60, 90 triangle. If it's not special, then you'll have to use SOHCAHTOA, your sine, your cosine, your tangent. Okay, let's review our rules for 30, 60, 90. What's across from the 30? L. So we know L is 6. What's across from the 60? L square roots of 3. So what is our apothem? 6 square roots of 3. So now we have our apothem to plug in to find our base area. And because our height is the same as our apothem, we now know our height as well. So we're going to plug that 6 square roots of 3 in for the apothem. And we're also going to say now that the height is 6 square roots of 3. Again, it doesn't say to round, so let's leave our answer exact. So what's half of 6? 3. What's 3 times 72? 216 square roots of 3 is the area of our base. Come over to your volume and plug that in. 1/3, 216 square roots of 3. And what was the height again? The same as the apothem, which was 6 square roots of 3. Again, it does not say to round, so we're going to leave our answer exact here. Go ahead. What's 1/3 of 216 times 6? What is it? 432? Okay, but that is 432 times, what's the square root of 3 times the square root of 3? Just 3, because it's the square root of 9. So what's 432 times 3? 1,296. Somebody agree with Christian? I agree with Christian. So 1,296, what are my units? Feet cubed. All right, guys, that one got harder. Questions? We still haven't dealt with slant height, though, right? Surface area becomes even harder. So now we're going to do surface area. Okay. Right now, you're going to see. Surface area. All right, what's my formula today for surface area? 1/2 PL plus B. The great thing is we already know capital B. And if you do your work neatly over to the side, you don't have to stress about finding it. You already know it's 216 square roots of 3. We also already know our perimeter. If you did your work over to the side, what do you have for your perimeter? 72. So the only thing we're missing here is our slant height. So remember that your slant height, I'm going to go back to my shape. Your slant height can be found by using your H height, your apothem, everybody with me on the apothem? And then your slant height. H height, apothem, slant height make a right triangle. Are we clear? So again, if you need to come draw it on a shape because you're having trouble seeing it, feel free to do that. Or on this shape, I'm going to draw it in. I'm going to use a different color here. So my H height is going to go from my vertex down to my center. And then I'm going to go ahead, instead of drawing my apothem this way, just because it's a little harder for me to draw that picture and see it, I'm going to draw my apothem from the center over to this side. Is that okay with everyone? Just so we can see it at a side view. And then my slant height is the height of this triangular face. So now you have this slant height, you have your apothem, you have your H height. Do you see that right triangle? I would probably draw it separate on my paper. Here is my height, my apothem, my slant height. Plug in the numbers that you know. What was the height again? 6 square roots of 3. What was the apothem? 6 square roots of 3, and we're looking for the slant height. Two ways we could do that. What's one way? Pythagorean theorem. I worry that you'll make a mistake when you square 6 square roots of 3, so I'm just going to warn you, if you use Pythagorean theorem, make sure you're putting that in parentheses before you square it. But what kind of right triangle is this? It's a 30, 60, 90 right triangle. Oh, it's not a 30, 60, 90 right triangle. It's a 45, 45, 90 right triangle. What tells me that it's 45, 45, 90? Okay, the legs are the same. It's isosceles. If the legs are the same, then the base angles are the same, which means this is a 45, 45, 90 triangle. It's going to be easier if you recognize that than it is to do Pythagorean theorem. But you do whatever makes more sense to you. I'm going to work it using 45, 45, 90. So what is across from the 45? L. Can I use a different letter since we have an L in our problem? Is that okay with you guys? So I'm not going to do L square root of 2. I'm going to do S square root of 2. So I'm going to call that S, okay? So what's across from the 90? S square roots of 2. We normally would say L square roots of 2, but I don't want you to mess that up with the L that's already in your problem. So if S is 6 square roots of 3, let's plug that in. L is going to be 6 square roots of 3 times the square root of 2. What does that give us? Exactly, Christian. 6 square roots of 6. That is our slant height. If you want to do Pythagorean theorem, I'll show you that over here just to make sure on the whiteboard. You have 6 square roots of 3, 6 square roots of 3, and L. Pythagorean theorem would be 6 square roots of 3 squared plus 6 square roots of 3 squared equals L squared. Be careful. 6 square roots of 3 squared means you have to square both, which means you're going to have what times what here? Not 6 times 3. Is that what you said? 36 times 3, yes. 6 squared is 36. The square and square root cancel, so you have 36 times 3, which will end up being 108, I believe. Am I right? Okay. And then the same thing here, 108, which equals L squared. Then you have to add those, and you get 216 equals L squared. And then you have to take the square root of 216, and you have to factor and simplify it. So it just becomes a little bit harder if you're doing Pythagorean theorem than it is if you recognize and use your special right triangles. But if you simplify this correctly, you'll still get 6 square roots of 6. Is everybody okay one way or the other? All right, plug it in. Surface area. We have 1/2. What was the perimeter? 72. What's the slant height? Careful, slant height. 6 square roots of 6 plus what was the area of the base? 216 square roots of 3. All right, let's simplify. What's half of 72? 36 times 6, 216. So we get 216 square roots of 6 plus 216 square roots of 3. And what are our units? Feet squared. And that is as far as we can go because you can't add a square root of 6 with a square root of 3. They are not like terms. It's like adding x and y. Questions? It's a little harder, right? Any questions at all? Okay, then what I want you guys to do is, in your groups, I want you to try this one. So go. Back up here with me. First of all, it's a 6-story square pyramid. What is the 6th story telling you? Okay, it's telling you the height. It is a 6-story square pyramid, so they're telling you that the height of your pyramid is 6 stories, right? And if it's 6 stories and they tell you that 1 story is 10 feet, remember how to do your conversion. If you have 6 stories, you want the stories to cancel out, so they need to go on the bottom, and the feet is what you're trying to convert to, so it needs to go on the top. So you have, in 1 story, there's 10 feet, so you're going to multiply. 6 times 10 is 60 feet. Is everybody okay with finding the height of 60? Okay. Then it says that you have a base area, so they're giving you what letter? Capital B. The base area is a 1/2 acre. But we want to convert that to yards, right? And it says that 1 acre is approximately 4,800, or is exactly 4,840 square yards. So if it's 1/2 acre, we want the acres to cancel. Put them in the bottom. In 1 acre, there's 4,840 square yards. So the acres cancel. So you're taking 4,840 times 1/2. So how many square yards is our base? 2,420 square yards. Everybody okay there? So what I saw when I walked around and you were trying to find the volume is that a lot of you did 1/3 area of the base times the height. You plugged in the 2,420 square yards, and then what did you plug in for the height? The mistake I was seeing is you were plugging in 60, but 60 is in what unit? Feet. So you've got to convert your 60 feet to what? Yards, so that you have the same unit of measure. So if I have 60 feet, do your conversion again. How many feet are in 1 yard? 3. And again, you want the feet on the bottom, so they'll cancel. So 3 goes in the bottom, 1 goes in the top. So we're going to take 60 and divide it by 3. So how many yards are in 60 feet? 20 yards. So we're going to multiply this by 20. Does that make sense? And yards squared times yards will give us yards cubed. So what is 1/3 times 2,420 times 20? 16,133 and 1/3 cubic yards. Questions on how to find the volume in cubic yards? Okay, so then what does it tell me? How am I going to convert that then to cubic feet? Be careful. How many feet are in a yard? 3. So what some of you may think is we're going to multiply this by 3, but that's not how many cubic feet are in a cubic yard. We've talked about that. So how many cubic feet are in a cubic yard? 27. If 3 feet is in 1 yard, you need to cube it to find out how many cubic feet are in a cubic yard. What's 3 cubed? 27. What's 1 cubed? 1. So in 1 cubic yard, there's 27 cubic feet. So you'll take that 16,133 and 1/3, and you'll multiply it by your conversion. This was yards cubed, so you want your yards cubed on the bottom, and you want your feet cubed on the top. Yards cubed will cancel, so you're going to multiply that by 27. What do we get when we multiply this by 27? 600, I'm sorry, what? 600 exactly? 600 cubic feet. Questions? Are you understanding how to write your conversion to determine whether to multiply or divide? Yes, no? Okay. Let me know if you're not. All right, let's look at, what else have we not done? We haven't done did we do this example? Yes, this was the hardest one. Okay, let's go to the end of our notes again. And this should be a super easy problem. So go to this problem. It should be the second to the last problem. Is that correct? Okay. It says the diameter and height of the cone are divided by 3. Describe the effect on the volume. We said yes last class period. If all dimensions are multiplied by A, what happens to the volume? It's multiplied by A cubed. If I have a cone, the only 2 dimensions in my cone are the radius or the diameter and the height. So if I am multiplying the diameter and the height by 3, or in this case dividing by 3, then I am dividing all dimensions. Would you agree? Okay, so when you write your answer, be careful. This is dividing by 3. So you would say the volume is divided by what? What is it? 27. 3 cubed. Or you could say the volume is multiplied by what? 1/27th. Your choice. I don't care how you word it. Any questions on that one? All right. Let's just talk about the last one, and then we're going to go back to the very first problem and talk about how do we find the surface area when it's not a regular base. So really quickly on the last one, we have this shape. You have a cone on a cylinder and a cone under the cylinder, right? Here's my question for you. Are the 2 cones in that picture the exact same dimensions? Look at it carefully. Are the 2 cones in that picture the exact same dimensions? Do they have the same base area? They're sitting on top of each other, so the circle doesn't change. But what's the height of this cone? 40. Remember that when they write a dimension like this, they're not telling you the slanted distance. They're telling you the straight up and down vertical distance. A couple of you on the last test, or overall in all my geometry classes, there were a couple people who messed up with that. So be careful. If this is written vertically, then they're giving you the vertical distance. All right, this whole thing from here up is 70. If this is 35, what does that leave for here? 35. So the only thing I want to warn you about is don't assume in your picture that your shapes are identical, okay? So for volume there, you would find the volume of the cone, the volume of the other cone, and the volume of the cylinder. So on tonight's homework, you may be going back and using some of your formulas from last class too, okay, when they put those composite shapes together. So be careful you're using the correct formula. Let's talk surface area real quick. If I want to find surface area, what am I not going to need for the cone when it's shaped like this? The base. So what is that called when all I find is this area? The lateral area. And then for the cylinder, what am I not going to need? The base on the top and the base on the bottom. So what am I really finding about the cylinder? Just the lateral area. So to make it a little easier, instead of having to find the whole surface areas and then subtract away all these circles, you could just find the lateral area of the cylinder, the lateral area of the pyramid or cone, and then the same on the bottom. Does that make sense? All right. Okay, let's go back to the top one. Very first problem, last problem for today. This is worst case scenario, or if it is not a regular pyramid. So again, when you're working these problems, it says find the volume and the surface area. For surface area only, you have to make sure that your shape is a regular pyramid. Okay? If it's not a regular pyramid, you can't use that surface area formula. You can still use the volume formula. It's only surface area that we have to worry about, and only for pyramids. So let's do volume really quickly. We want to find the volume of this rectangular pyramid. I'm going to go ahead and draw a rectangular pyramid. Let's label our rectangular pyramid. It has a length of 11, a width of 18, and a height of 23. Where's the 11 and the 18 going? On the base. So one of these is 11, one of them's 18, and are they giving me H or L? H. If they say height, that means H. If they're giving me L, they will give me slant height or lateral height. They won't say height. So volume here should be pretty easy. What's our formula today? 1/3 capital BH. Find the area of the base. How do you find the area of our base shape? Length times width, or 18 times 11 I was hearing. So what's 18 times 11? 198. Okay, and then we already said the height is what value? 23. So I'm going to plug those into my formula. Everybody okay so far? So we have 1/3, 198 times 23. What's our volume? Help me out. What's 1/3 of 198 times 23? 1,518, exactly. 1,518 units. Meters cubed. Okay, volume's easy. The part that's harder is finding the surface area because you cannot use your formula. So you're going to have to think about this as 5 separate shapes. You've got your rectangle on the bottom and you've got 4 triangles. Are the 4 triangles around the rectangle all congruent? No. And that's what makes it a little harder. Okay, so we're going to try to find the area, surface area, but we're going to have to break it apart as a net. So you've basically got a rectangle, and then you've got triangles. And I'm going to kind of run out of room there, so that really should go on out, but you get the idea. So you've got 4 triangles and your rectangle. So what's the dimension for this rectangle here? We'd have 18 and we would have 11, right? That means the base of these 2 triangles are going to be 18. The base of these 2 triangles are going to be 11. What are we going to have to find in order to find the area of those triangles? Slant height. Is the slant height going to be the same for all 4 triangles? No. So that's the hard part, okay? So let's start with the easy part. Let's find the area of this rectangle in the middle. So we've got a rectangle. Area of the rectangle, we already did, didn't we? Base times length times width, 18 times 11, 198. Are we okay with that? Okay, we need to find the slant height. I'm going to start by drawing a right triangle over here and making a slant height. Which triangle's height am I finding? The one with the base of 11 or the one with the base of 18? So notice I'm drawing this slant height over to this base. So that's the base with the 11 on it, right? Everybody with me? So that means over here I'm finding this height right here if I find that slant height. Okay, so let's do it. We have this right triangle. This is 23. We're trying to find the slant height. What is this distance? 9. It's going to be half of this length, which is 18. So that is 9. Oops. Okay, do Pythagorean theorem there and let's find L. So we have 23 squared plus 9 squared equals L squared. What's 23 squared? Nobody wants to talk to me. I know 9 squared is 81, but I don't know 23 squared. A little louder, Hallie. 529. So add that to 81 and we end up with 610. Okay, so 610 equals L squared, which means L is equal to the square root of 610. Okay, and again, that's the height of the actual triangle here, square root 610, which is the slant height on that side of the rectangular pyramid. Okay, so we want to find the area of the triangle that has a base of 11 and a height of square root 610. So what's my formula? It's a triangle. What's our formula? 1/2 base times height. Okay, plug it in. Tell me what you get. Mrs. Lashley. Yes, ma'am. Okay, I'll send her thanks. Bye-bye. Shelby, you need to go down and see this price real quick. Okay, I didn't ask you. Can we simplify 610? Like, will that factor? I know 2 will go into it. How many times does 2 go into it? 305. And that factors into 5 and 61. And 61 is prime. Is that correct? So I think that it will not simplify, right? So let's just leave it 610. So we have 1/2, 11 times the square root of 610, which is just what? 5.5 square roots of 610. But that's for each triangle. And how many of those do we have? 2. So we're going to have to multiply that for 2 of those triangles. So that's going to be 2 times 5.5 square roots of 610, which goes back to 11 square roots of 610. Are we good with that? So we have this 198. We have this 11 square roots of 610. What are we missing now? The other 2 triangles with a base of 18. Okay, we got to find it. Do you see why using the formula becomes so much easier if it's a regular polygon? Breaking these apart become time consuming and long. All right, so we need to find this height, right? So now we're going to draw another triangle. We're going to go from here over and find this slant height. It's a little harder to see when we're going to the front or to the back. This is still a height of 23. We're looking for this slant height. What is this distance right here going to be? 5.5, half of that side of 11. So this is going to be 5.5. So I'm going to redraw that triangle over here. 5.5, height's 23. We're looking for our new slant height. And that's going to give us this distance here. Okay, do the Pythagorean theorem. 23 squared plus 5.5 squared equals L squared. We already know, somebody told me 23 squared was 529. What's 5.5 squared? 25.25? No, 30.25. Equals L squared. And then combine like terms, so we have 559.25. So L is equal to square root of 559.25. Okay, what are we going to do to find the area of the other 2 triangles? Is this correct? You guys with me? Sort of? All right. So now we want to find the area of these 2 triangles. 1/2 base times height. So we have 1/2. Our new base on this one is 18. And our new slant height we found was the square root of 559.25. It's terrible. This was 18. So what is half of 18? 9. But again, we have 2 of these. So we're going to multiply it back and get 18. So the area of the other 2 triangles, I don't know why it keeps erasing, is going to be 18 square roots of 559.25. Okay, take your calculator, add it all together. These 2 areas plus these 2 areas plus this one. Add them all together and round. Tell me what you get. Everybody plug it in. Check. Anybody have an answer yet? What's our volume? Or sorry, surface area? Nobody has an answer? Somebody scared to answer? Brendan, did you get an answer? What'd you get? That's what I got. 895.4 meters squared. Did anybody not get that and not understand where they went wrong? Okay, guys, it could be this hard. Christian? Mm-hmm. You can't add what? Right, so we couldn't add this and do like 610 plus 559. We couldn't add them without using a calculator. We can type them in and add it all together, you're right, but we can't add them as far as simplifying goes. Okay, other questions? Okay, that's as hard as it's going to get. More than likely, it'll be more like these, where they're regular polygons on the bases, but those still got kind of complicated with finding your apothem and your slant height. Any questions overall? Okay, I will warn you that